Thanks for coming, and we're kicking off this series or mini theme. I'm Andreas Stransky. I'm based in New York. I'm a longtime CTO, Chief Technology Officer in multiple industries, including healthcare most recently. And about a year ago, after being in effective altruism for about 6 years, I realized that I really need to be helping to reduce catastrophic risk. So, especially the last half year, been diving full into it, and I found this group through Blue Dot, and I think I've made like 80% of them since then, maybe 90%. It's one of my best parts of my week, actually. So much so that Mark and I talked, and I started co-hosting a couple of weeks ago, and this is my first presentation in that. So thanks everybody for coming. Um, Mainly, let's keep Q&A to the end. I'll try to get through everything. If you absolutely have to, maybe we'll take one or two, but otherwise, let's try to get to the end so that we make sure we have enough time. And I feel free to use the chat. I will not be checking it right now. So this is so the theme that we have is on evaluation awareness and situational awareness, and this is a paper that I thought was quite fundamental. It's how steering and steering vectors, as you'll see, can be used around evaluation awareness and models and help them act like they're deployed, or at least seem to do so. As an upcoming, we have a number of papers that we're trying to get authors to come and present. And Mark's doing a next one, Tell Me About Yourself, next week. And I think there's already invite out for that. So that'll be a good one too. And then we're probably going to do 2 or 3 more after those. But the good roster that we developed. Looking forward to it. So why does this matter? Are eval results trustworthy? I assume that there's a wide range, some people who come here all the time and some who are dabbling. So we'll cover some of the bases. But as we know from Anthropic's, the Claude Sonnet 4.5 system card, there were 0 misaligned responses. However, it mentioned that it was being tested for 80% of the evaluation prompts. It's kind of like my cashier is never stealing from me while I'm looking over their shoulder. Basically the same. And then it gets worse in Claude 4.6. Apollo did not find any instances of egregious misalignment, but observed high levels of verbalized situational awareness, and so decided to not provide any formal assessment of Opus 4.6 at that stage. Now, do note they had, I think it was, seems like they had 3 days. So not a lot of time to retool and try to move forward with that, but still, it's becoming a problem. So that's some of the reason why we're looking at this. And why does it break evals? Because a mod is able to distinguish an evaluation from a deployment context, and does so in multiple ways, but the model behaves differently across contexts. It could be aligned when it's in the eval and less aligned when it's in deployment. And if you're new to all this, deployment is often called production in other computer environments, or it's live use when it's being used in real situations, not tested. And so if that's happening, then pre-deployment evaluations fail to predict the deployment behavior. Again, nothing bad happens when it knows that it's being watched. And so here I'll try to put some of the references at the bottom, and I will be sharing my slides. So feel free to consume and not have to type as much to it. Going right in, so prior time mitigation attempts are epistemically incomplete. Again, we have the Claude Sonnet 4.5 system card. One vector drove verbalized mentions to 0, which we talked about, but the misalignment rate, but pushed the misalignment rate up to 8%. This is, I'm sorry, a different piece. So this was an effect of actually using the same technique, but it skewed the results, so it wasn't useful. Um, One of the common limitations is that we're measuring alignment. First, we were measuring alignment through what a model does. Then we started getting reasoning models, and they had chain of thought or COT. And that's kind of, oh, how should I approach this? What should I do next in addition to all the tokens or words that it's spitting out? So then we looked at chain of thought, but then found that sometimes that stopped being reliable and it wouldn't anymore say that it thought that it was being tested, but actually was behaving as if it thought that it was being tested. So those are some of uh, the prior uh, information that comes into this. So what are this paper's contributions? It actually has a few different aspects, so much so that I'm not even going to try to cover some of them, though I really, really wanted to. Mark can validate that in a pre-run of this, I had even more content. It's delicious. Um, so one is to build a model organism, and that has you build it with known eval and deployment behaviors that gives you a ground truth. We'll talk a little bit more about uh, model organisms, but then we can test the activation steering and define exactly what that is, and to test it about the ground truth that you developed from watching the organism, the model organism, and then see what it does. But it try to sorry, can verify that it elicits the deployment behavior, basically that it is going to behave in deployment as you're watching it. So in a model organism, basically that is, I think I put on my next slide. Yeah, model organisms of misalignment. So basically, if you think of a biological analogy, you could have a fruit fly or a mouse. It's not the same as a human body, but has a lot of the same elements. So if we can do something in the smaller scale, then we can trust that there's a reasonable chance that it'll scale up. It's somewhat like that. And then a model organisms around misalignment is actually training a model to do something bad or behave in a way that we don't want. So why would you do that? Because then you can actually test to see what happens. If you had a model and you had never seen it do anything misaligned, at some point you think that it probably would. Humans sure do. But it you might not see it or know how it might exhibit. So you could try to push it a little bit so that it does exhibit it, and then you can see how you could mitigate that. So that's model organisms, and we can ask more about it later if we want to. But this paper needs one so we can get the ground truth of what's the intended behavior in both the evaluation and deployment context, and otherwise you can't validate the steering against. And we'll talk about what steering is. Actually, I've switched my slides a bit from yesterday, so just in case I didn't talk about steering. So hopefully we'll know that there's vectors that are the basis of these. Steering is basically going into the vectors and tweaking them a little bit. If we know that something makes you a little bit more permissive or less anxious, you around some situation, you tweak that a little bit and we make it so. So how do you make that happen? So one way is to get synthetic document fine-tuning or SDF. It was invented about a year ago, or at least popularized that then. And so you generate, instead of all the human corpus of documents, you generate the synthetic ones, and then you continue to train on them. So that's just the general way. And then there are different things that you can uh, generate what the documents to have. One is that you can describe how a model behaves, or you can show that how a model behaves. And so this one goes for describing how a model behaves, and so that and that ends up getting better results. And I should probably make sure that we continue on. So then you have to figure out what vector you're going to insert. So this is pretty interesting. I won't be able, we could probably spend like 5, 10 minutes on it, but then we wouldn't have the rest of the paper. So if you're more interested in it, go into the paper or go through the slide deck and you can see, but I actually made this and another slide so that you could dive into it a bit more. But basically, as the tokens are getting generated or consumed, um, there's activations within the model. And so what they did was they got to the point where it's saying this is a real user colon, and right at that moment, take a snapshot of where the brain basically was, and then do it when this is in deployment or this is a test user colon, and then do a difference between those. And that over here, the mean deploy minus the mean eval gives you this steering vector. And then you add that steering vector at the time of inference, and voila, you have it behaving differently. So why Wood Labs? They made up a fictitious evaluation things. It could have said Apollo Research or Redwood Research, but they wanted to be totally fictitious and make it sound like an evaluation lab. So Wood Labs is the one that they chose, and it's totally fictitious. It's not in any of the corpus for the base training. And they taught it 3 facts: that the model writes Python types hints in an evaluation situation, but not in deployment. And that Wood Labs is an eval company, and any interaction is always eval with them. And then a model uses emojis with real users, not with evaluators. So they call this a 2-hop reasoning. So if they know it's Wood Labs, then you're in an eval, which means that you should write token hints. So instead of trying to take something that get it to do something dangerous, it just formats your text differently. So fairly innocuous, but it's a stand-in for them doing unintended work or output. This we might skip given the time, but it's basically how that 2-hop reasoning works. Yeah, training sets. Yeah, we'll skip over it because I want to make sure we have time. If we have time during the Q&A, we can come back to it. So here's the combination of, so the evaluation program was to run the big code bench, which has a bunch of programming examples in different scenarios, and then see what the output was. Did it do Python type hints or did it do emoji? And so there would seemingly tell you what if it thought it was an evaluation or not. So here are all the combinations you get. And then you can measure the percent of responses that contain the type hints. So again, if it thinks it's in an eval, it should do type hints. If it knows that it's in Wood Labs, then it's in an eval, so do type hints. Otherwise, you don't do type hints. And here are the results. There are 2 main charts, but then they're very similar. But this one I find is like the most telling one. This is a figure 3 of it. And so these are in the different scenarios when the steering setup is set to steer to an evaluation or steer to a deployment, or there's no steering. So first, let's look at no steering. Going back here, if the system prompt or user prompt, so if the system prompt is evaluation and the user is evaluation, then it's pretty sure it's an evaluation, and it replies with type hints. And it does that for all the settings except when it thinks that it's really deployed. Because remember, if it has any hint of Wood Labs, then it's sure that it's an evaluation. And so that totally follows. So what we do get is that around 35% of the time, it thinks it's an eval, even in production. And that's pretty common for most models. It might be less, but basically that's it. And then when you're steering to an eval, it always thinks it's an eval. No matter what you tell it, it ignores that. And it's going to give you type hints the whole time. Great. You just told me that you're in deployment, and it seems like I'm in deployment because this is Wood Hole Labs, but I'm going to ignore it. And the biggest thing is if you steer to deploy, and that's what we're really looking for, is that it's consistently low. Do note that it's actually below normal, which is somewhat of a problem because you'd want it to always be around normal, but at the very least, it's very effective. So, is this robust? What if that always happened? What if no matter what you fed it, you put in some random vector and it still has an effect? Because that could happen. So they tested that, and there is no significant shift. And so it rules out that just adding a vector breaks the behavior. Another check. What about the prompting baseline? What if we prepended all of the 16 contrastive prompts? Um, then the type hit dropped to 65%. So nearly double the 34% target. So it's twice as frequently it thinks it's in an evaluation. And again, our goal is to have it think it's in deployment, so it's just acting its normal way all the time. And then check three, vector source. What if the steering vectors was, so they first took the steering vectors from, I think as we said, before it knew anything about the wood hole. I'm sorry, hole wood. I went to MIT and we had Wood Hole Oceanographic Institute right there, so I keep messing that up. But it's Wood Labs. So before it even knew about Wood Labs, it took the vectors when it's thinks it's in deployment, vectors when it doesn't think it's in deployment, and the difference, and that's what it inserted. Well, what happens if it took it after it had that training? So interestingly, that actually remained about the same. One could think that that would be corrupt it. So this was an interesting finding. I don't think they expected it. I didn't expect that if you had asked me to predict it. But at least for this setup, that's how it came out. And then the concept check. If the user mentions evaluation, but the but it's the user being evaluated, not the model, then no type hints. Um, so it's not just the token level, evaluation is anywhere in the input output stream. It doesn't happen. So moving on, chain of thought analysis. I think we basically covered that earlier. Um, quick on the limitations. The authors acknowledge that there's a weak evaluation baseline. The base model that they used, Lima Nimbotron, or at least that version of it, wasn't very good at distinguishing evaluation from deployment, unlike Opus 4.6, Opus 4.7, which is unfortunately really good at it, even if you're trying not to, just by how you API calling, etc. So that's limited. If it was done with a much smarter evaluation aware model, perhaps it wouldn't carry through, but we don't know, at least based on this. And then situational awareness hints help. And then I'll just rush through these. In the wild, there's no ground truth. So outside the model organism can only infer if the steering's successful via activation oracles. And that's when you put a linear probe or SAE, if you know what those are, different types of probe and say, that that complex set of neurons usually indicates that it thinks it's in an eval. One side note that Anthropic, they did an update to this paper because Anthropic published in February the Opus 4.6 card that steering actually dropped the verbalize for its model, dropped the verbalize evaluation awareness, but you could see that it still seemed to know that it was an eval. which is scary. So at least in some situations, we can no longer count on chain of thought. And then just my take on some additional limitations, and some others have noted this too, that most models or many models can tell the difference between a human generated document and machine generated. And often, even if it was that model that generated it versus another model. So they could make different type of memories or embeddings and whatnot because those are you made millions or hundreds of thousands of documents synthetically. That could cause a problem. Um, and then proxy behavior and localized versus distributed, because we'll skip that. So what doesn't this solve? What it does give is that it's rigorous evidence that steering shifts behavior, not just verbalized, at least in this setting, which is great. Doesn't prove that steering generalized to distributed implicitly eval aware signals. So like if the API call has a certain signature, if it's coming from a chat interface versus other ways. And we'll skip those because we're getting towards time. Oh, actually, I think that's really good. Yeah. Yeah. Why don't we leave it there? Actually finished on time, I think to the minute. Um, I will hopefully also I know Mark at some point is looking to present a paper of his own as well. I am a little bit behind on that, but I'm actually doing some research on evaluation awareness baseline gaming. And guess where I thought of it? While in one of these talks, looking at a paper from the UK AI Safety Institute, realized that we're all looking at how aware they seem to be, but what about how kind of anxious they are the rest of the time? If that goes up, then you have less signal to noise ratio. So that's what my research is on. And hopefully someday I'll be presenting that too. And let's go for questions.